Good morning, YouTube. We are back at Exotic Power and Performance because today we're going to play with some distributors.
So are you recording all of the nefarious activities?
If you're new to the channel, my name is Dan, and well, this is actually Josh's shop. This is Exotic Power and Performance. You guys know and love Josh, and you know he's going to harass me today, so I know that's why some of you want to watch these videos.
Shut up, Dan.
I rest my case.
Shut up, Meg.
Well, anyway, today we've got some distributors. He's going to show us all about them. I am kind of scared of distributors, admittedly. I don't really know that much about them. And we also have a giant stack of engines needing work in here. So this is the engine room. But also, if you want to support the channel, just real quick, go visit normalguysupercar.com. There you can buy parts and services. Use the code NGS10. It'll hook you up with 10% off. And also, if you want to support Josh or have him do some work for you, go to exotic-power.com. And he can get you set up and, well, do stuff like this and spread his knowledge. And you can learn stuff.
At least the first 8 letters of the alphabet.
Ooh, really? You know those?
I'm good to the 8th letter.
Okay, I only got like 6.
A, B, C, D, E, F, J,
Damn.
L, Q, R, Ferrari.
Yeah,
Yeah, A, B, C, D, E, F. Yeah, we'll go with 5.
Italia.
Yeah. Good enough.
You'll learn some new cuss words too.
Oh,
Sure.
definitely.
We make them up as we go along.
Inventive cuss words. All right, Josh, what are we doing today?
We are playing with distributors, specifically Marelli distributors, used in 60s and early 70s era Ferrari and Lamborghinis. They also were used in Maseratis and some other stuff. We've got a pair of Miura S85 distributors. One's mounted up on the test bench, one's all assembled on the workbench, and then we've got some guts in a US spec Daytona or a 365 GTB4 unrebuilt distributor there. So we've got a few different bits of a Marelli distributor in various states of disrepair and repair. So we're going to do kind of a crash course on what's in them, why those pieces are in them, what they do, and then how we interrogate them, evaluate them, and tune them, and why, if your shop doesn't understand and do these things, it's a fucking joke. So obviously we've talked a lot about fuel tuning on engines, right? Because we played with the carburetors, we tuned some carburetors, we did some idle mixture pod adjustments on the F40.
I can't believe how smooth that idle suddenly got. That is
Yeah.
really impressive.
That was really cool.
Trust your mechanic, Glenn. We've done the ECU flashes on like your 458 and your 430s. So we've talked a lot about fuel mapping stuff and just briefly kind of glanced around on ignition stuff, right?
Yep,
But we've
yep.
talked a lot about fuel oriented shit. Obviously, fuel only gets you so far. You've got to ignite the combustion, right? Spark ignition in a 4-stroke engine really hasn't changed ever in the history of 4-stroke engines, right? The coil unplug ignition in your 458, the fundamentals and the principles that it operates on are identical to what this 1960s ignition and distributor does here, right?
Yep.
I won't go into crazy detail because you can Google this stuff pretty easily, but the basic idea is you've got an ignition coil that takes 12 volts from the car's fuse box, primary system, multiplies that,
Yep.
outputs 8 to 40,000 volts, right, through the coil into the spark plug.
Yep.
Right? That's the short version of it. Well, they all still do that. They've always done that. That's not changed. The difference is we used to mechanically control the ignition. Now we electronically control the ignition, right?
Right.
Your car has a computer, so it uses a microprocessor, a driver, and that cycles the electrical current and sends the charge to the coils, releases the charge so the coil can fire, changes the timing curve, which means when the ignition fires relative to the top dead center of the piston at the power stroke, right?
Right.
That's all still the same stuff. We're just doing it differently.
Mechanically versus computer.
Yep. And so the advantage is this little guy, it can only really do one thing. Okay, it has a mechanical advance curve, it has a fixed mechanical phasing, and that's it. End of time. Engine RPM determines how much advance from 0 that this distributor makes, right? It never changes. Doesn't matter how much you're in the throttle, how much you're off the throttle, how much vacuum the engine has, all that stuff. this distributor only decides timing based on how fast it's spinning.
Okay.
End of story. Later on, they added vacuum capsules and stuff to some of the distributors, so you got vacuum retard and vacuum advance, and they got slightly more complex, mostly for emissions control stuff, not performance. This is a very dumb system, and that's why we don't use these anymore.
So it's basically just using centripetal force, right?
That's it.
The
So,
faster I spin, the further it presses out.
yep. So this is the base here, right? This guy will attach to the camshaft. This will mount to, see this, you see here, right?
Oh, yeah,
so
yeah,
you
it
got the
slots in.
housing. Yep. So this is the main insides, right? That will spin as the engine's turning.
Yep.
This is a weight, bronze weight on a hinge point.
Okay.
Inside here, this is a pin with a cup and a spring. See that?
Oh yeah. Okay.
So exactly, as it spins, the centripetal force brings this guy out.
Yep.
So the stiffness of the springs determine how much RPM is required to get these guys to fly out. That determines how much timing advance you get per engine RPM.
Right.
So we change the stiffness of this to either slow down or speed up the timing advance. And then this bushing here where it rests against, you can see this is a metal sleeve. This sleeve changes the distance, right? This here is your total timing curve, right? The amount of distance this guy slides across here.
Okay. Yeah.
So this being a very thin bush, let's assume this is a 30-degree curve,
Okay.
right? And 30, when I say 30, I mean at the crankshaft.
Yep.
This guy spins half speed of the crankshaft because
Yep.
it's on the cams. So really, on the machine, on our test bench, this will be a 15-degree change. On the engine with the timing light, it'll be a 30-degree change.
Right. So you gotta multiply everything by 2.
Yep. So if the engine's running and you're using your timing light and you set this up at an initial fixed advance, we call it, of 10 degrees, once you rev the engine up to say 4,000 or 5,000 RPM and you reach maximum total advance, let's say that's a 30-degree curve, so now you have 40 degrees. This little bushing and the amount of travel on this weight is what determines how many total degrees of advance you get, while the spring decides how quickly that happens.
I'm
Well,
assuming a lighter spring means it happens faster. Heavier spring means slower.
correct. Yep. And on that note, so there you go, there's kind of a quick breakdown on how that guy works. This one looks like it runs pretty much the same spring on both weights, but like in this Mura distributor, one has a longer, softer spring. That's the first half of your advance curve. And then this guy's got a shorter, stiffer spring. So once this weight's, once the weights have come out to a certain point, you've overcome the spring rate, of the soft spring, and now you're fighting the stiffer spring here, and that slows the curve down. So you can actually, it's not always just a linear change in timing by RPM, right? It's not every 500 RPM you get, 5 degrees of timing advance
So
necessarily.
would it be like 2 different slopes? So you have one slope and then a second slope?
It depends on how the spring rates overlap.
Okay.
Right? It could hitch up. Usually it's fairly linear, so you'll either get a straight linear or you'll actually get kind of like a curve,
Okay.
an actual curve, and that's why we call it an advanced curve.
Okay.
Yep. So you can already see right now there's several things to consider when you're really trying to tune one of these distributors, right? One is making sure that the brass weights are the correct weight,
Yep.
right? Because if someone's got in and shaved them and mucked with them, it'll be a different weight. You also have the springs and making sure you have the correct springs with the correct resistance. And you can shim these guys too. If you can't get quite the right spring, you can shim them to create a little more, load resistance. So you've got a couple factors there. Then you've got this bushing here that determines how much total, curve you have.
Yep.
So right there, you've got a few things to consider. Now we go up to the next level. You got this little guy here, slides down on the shaft, and now you've got this interaction with this bushing here. Because as you see, it's a round pin, right, with metal slots. So if you were to just, instead, you get this little bush here with some flats. So these wear out. So you got to be aware of these as well, because now the question is, all right, so the weights move and that changes our timing advance.
Yeah.
But how? Right? Because our drive is fixed to our camshaft.
Yeah, it's going the same speed.
Yep, so the housing's bolted, the drive is mounted to the camshaft. These things can't change. These weights move. Why do they move? How do they change the timing? Okay? Well, the way they change the timing is, see this here? When this guy activates, let's see that?
Yeah.
Okay.
It rotates it.
See how the tri-lobe cam there moves? Okay. So we're talking about points distributors, right? It's known as points. Really, it's a mechanical breaker.
Okay.
When it's closed, it's completing the ground circuit through the ignition coil, right?
Right.
So you got battery power to the positive of the coil. From the negative, it runs here. When this guy is closed, because your distributor's mounted to the engine has a ground cable to the chassis has a ground cable to the battery, you've completed the ground circuit.
Gotcha.
So as long as you have a completed circuit through the low tension side of the ignition coil, it's absorbing that power and multiplying it to build the charge so it can put out 8 to 40,000 volts, right, to fire the ignition. When this lobe rotates and it breaks this one's wore out, it looks like. When the lobe rotates up off the flat here, it opens the breaker. And when the breaker opens, you lose that ground.
Yep.
The coil still needs to find ground. So now the coil throws the electricity through the high tension side, which is your coil wire, through your distributor cap and your rotor, through your wires, through your plugs into your motor. Because your spark plug threaded in the motor is actually a ground point.
Right.
So when you break
With a
this
small
open,
gap.
Exactly. So when you break this open, now you've broken this ground circuit. Your coil's charged with, let's say, 10,000 volts. It needs to find, it's got to find a place to
go the path of least resistance.
Exactly.
Which hopefully you're not touching it.
Yeah. Bodies make a great path of least resistance. Now, as you can see, this plate with these points bolted down fixed, right?
Yep.
So how do we get our actual timing advance? Well, as you can see here, when this guy activates, it rotates the lobe, right? So now what you're doing is you're changing, as this rotates, let's say, 360 degrees, right? Well, now, when you advance this, you've forced this rotor forward 1, 2, 3, 4, 5, 10, 15, 20 degrees. So now it hits the points sooner,
Yep.
opens the point sooner, and now you get your ignition firing sooner. That's how you get your advance from your ignition on a mechanical distributor with points.
And there's typically 2 points in there?
Well, it depends.
Or it depends. I mean, so, because I'm just like thinking, okay, so this is for a V6, right?
Well,
This particular one.
well,
Or it could be?
Well, this is a V12 distributor, and they use 2 of them, right?
Yeah.
This is also a V12 distributor, and they use 2 of them.
Right. So
No.
each distributor is firing 6 cylinders.
Yep.
And then you've got 2 points, so or 2 lobes. I'm trying to do the math here in my brain, right? So there's 2 lobes.
So this is where it gets more fun.
Oh, but if it's going around twice, so it's at half speed, so it's actually 2 full cycles, right? So it's, I don't know. My math is retarded.
Yeah, no, you're pretty close. The distributors alternate, right?
Yeah.
One fires, then the other fires, then
Right.
the other fires, and on and on and on, because
Yeah.
you got 2 of them running 2 inline 6 cylinders in this instance,
Right.
and so they're going to fire in sequence,
Right.
to run the motor, because it's always one side or the other. But as far as the points go, in this application, there's 3 different ways that you might see the points configured depending on which car you're working on, okay? On this case, like this Miura distributor, right? This is a 6-cylinder distributor on one side of a V12, 3 lobes, 2 points, okay?
Yep.
In this application, the
3
way...
lobes, 2. Okay, so
Yep.
now it's 2 times 3 is 6.
Not really.
No, oh, well,
I mean, yes, but also the points are set up so there's a period of overlap between the 2 of them, okay? And so that creates an extended period of dwell.
Okay.
Dwell means we get more charge time on the coil. So yes, one set each fires 3 cylinders, but really each set works in overlap with each other to create a dwell as well. Okay? If we had 1 point on a 6 lobe, very little dwell, and it's going to be based on your points gap. And when people talk about points gap and gapping points, that's why you gap points as a set dwell. So you're determining the period of time that it spends closed versus the period of time it spends open in degrees,
Gotcha.
right?
Okay.
Because the firing event, only needs so much time to happen. The coil will discharge within a pretty, set amount of time.
Right, so then you want to start charging as soon as possible.
Yep. Yeah, to a degree,
Right.
because
You got to give it enough time to discharge everything.
Yeah, because it's got to have cycle time. So a 4-cylinder will have a longer dwell than a 6-cylinder, and then on to an 8-cylinder. If you're talking about because we're going to say single distributor applications, right?
Right.
So a 4-cylinder engine might have 90 degrees of dwell, whereas or nearly 90, whereas a 6-cylinder, will have nearly 60 degrees, whereas an 8-cylinder will have nearly 40 degrees.
Yeah.
42 really. 3 lobes, fire 6 cylinders with 2 points, right? And there's a period of overlap here between the 2 points to get maximum charge on the coil for maximum ignition
Okay.
power. This, being a US spec Daytona, has 6 lobes on it.
Whoa.
These distributors also have 2 sets of points, but what they did here was one set of points is your primary. Your second set of points is set up in a retarded position. And then you use a micro switch that's activated by the throttle linkage to decide which points you're going to run on. So that way when your engine's idling,
Oh, wow.
you run on the secondary set of points with retarded timing to help pass emissions. And then when you open up the throttle and start driving, now you open up the primary set of points, and that's what you run on. So this engine runs on one set of points at a time based on what you got going on. The Euro cars ran a 3-lobe, dual point distributor, more performance oriented. This is very specific to the US cars. Now, if you go even later to like the 365 400i GT cars, right? The 4-seater cars, they actually just went to a single set of points with a 6-lobe distributor on each bank because who cares? The 400, it's not worth talking about. So now you get talking about points and calibration, right? So now we know that we can change the gap. Like you can see here, there's no gap, right? These guys aren't opening. Of course, there's play there, but that's not opening, right? But then we come over here to this guy. See that?
Yep. Just barely see it moving.
Right?
Yep.
So when it's open like this is when you set your points gap.
Yep.
And this is what we use to determine basically how long it takes for the lobe. Because see, well, you probably can't see, but see how there's a flat here, right?
Yep.
And then you come into the lobe. So when you're adjusting the points gap, you're adjusting how far, the foot is from the lobe. And that will determine how long, where on the lobe point it hits, right?
Gotcha.
So the deeper in it is, the sooner it's going to be able to catch that lobe, the sooner it's going to open and the longer it's going to hang open for. And the less time it's going to spend closed, and vice versa, right? If you bring this far away, you're going to get really deep into the peak of that lobe before it actually pops the points open. So you've had a really long dwell time with a fairly short fire time. That's gapping the points, and that's super important. These are, ignitions in general are really sensitive to dwell time, and distributors because it's such a in-your-face mechanical thing. So you've got that factor to worry about. You also have manufacturing, quality differences in the points. So these guys aren't always perpendicular. Sometimes, one will be off, so you don't get a full face contact. The point will be trying to touch, and you
Right.
get a less complete, and we all know that, contact surface is important in conducting electricity, right? So you want to make sure you got a flat face. You want to make sure that the point faces aren't offset. Like maybe you can see on this one, there's a pretty big offset right here. These 2 point faces are not really parallel with each other. One's, a bit higher than the other. So we have, reduced surface area contact between the two. So that's an area that I'd want to adjust. Another thing is you'll see that this has, 4 copper leaves, right? And those are springs. That big copper loop there is a spring. Whereas you'll see on this one, there's only 3 springs on it.
Yep.
So this has stronger resistance, right? So it's going to
take some more effort.
Yep. And which also means it's going to snap back more aggressively.
Yep.
As we talked about here, where you have 2 sets of points, idle points and running points, we'll call them. Your idle points may only have 3 springs in it because it's going to run at a really low speed.
RPM.
Yep. Whereas your high speed will probably have 4 springs in it to hopefully maintain better control at higher RPMs.
Yeah.
So another test you would do if you were diagnosing, let's say, an old distributor and you wanted to see, what kind of shape it in, you'd use a strain gauge and pull on this to see how stiff the spring is and make sure that you have adequate spring resistance. Because if you don't, when it's going through its cycle, it may actually hit and then bounce off, and you'll get some fluttering because you don't have adequate spring strength to keep it shut when it's supposed to be shut. It might flutter.
Yep.
So, spring strength is fairly important. Condenser.
Yeah.
Dan, what do we know about condensers? You're an electrical guy.
No, I'm a computer guy.
Really, this is, you could call it a battery or a damper, right? It doesn't literally generate electricity, but it does help absorb and smooth the cycling of electricity, right? Because as these points open and close, they're turning on and turning off the ground circuit for the ignition coil.
Yeah.
Right. So you're getting electricity just shunted through this constantly. So your condenser helps control and smooth that, so it doesn't become erratic and you don't get flyback voltage and and weird stuff like that. When these guys go bad, they cause some pretty wild issues in the ignition system as well, because now the coil may not be cleanly and in a timely manner discharging, the connection and disconnection might not be, on those. You'll see on the guy we have on the bench, right? So that's wired to this stud. This is where your ignition coil ground lead would connect. You'll see here our points wires are also connected to that guy. So that's our main electrical pass.
Okay.
Right? That's really kind of a good overview of
how they work,
how the distributor works.
Yeah.
Questions from the peanut gallery before I wander off into running the machine and we look at what testing and calibrating looks like.
So none of these have vacuum advance. They're all
Correct.
But this one is the weird one with the 2.
Correct.
Okay. So when they switched to vacuum advance, I'm assuming that kind of became obsolete.
Correct.
Okay.
Yep. Now you would have a vacuum capsule with an arm that would come in, and this plate for the points now rotates.
Okay. Oh, so it actually shifts where that is physically.
Yep.
Oh, okay. That
Yep.
makes sense. So
Yep.
that's how you get it to... Because I was thinking like a vacuum is going to be pretty weak compared to those big springs. And okay.
Yeah, I mean, 20 inches of vacuum is no joke.
Yeah, I guess that's true. That's pretty strong.
Yeah. Yeah, but yeah, exactly. You're not you're not controlling the point itself. You're controlling the plate, which is on a pivot and chain.
Okay.
Yep. Yeah. So you're doing the same thing that we're doing by having offset points that hit, at different degrees of rotation. You're just changing the point at where it hits the lobe through a vacuum actuated arm. Yep.
Very cool.
Yeah. Okay.
Okay.
Other question?
I want to see this thing do
Adam?
something.
I was lost 20 minutes ago, and we've only been at this for like 15, so.
Perfect. I expect nothing less. All right.